Over 500 Republican candidates received more than $100,000 in individual contributions for the 2020 election year. Data collected from the FEC are displayed in the histogram below. We want to describe the distribution. Well, the first thing that I see here is that this is skewed to the right. And I also see that it looks to be unimodal. I only see one bump. I also can kind of tell that the range goes from 0 to about 14 million. So range from 0 to 14 million. Now let's go ahead and use the statistical tool and the data given. So I have it here. We're going to highlight all of that data. Let's go over to the statistical tool. We're going to build our own. I'm going to put in the data given, hit enter. And now let's look at this question, part B. We want to use the statistical tool to construct the sampling distribution of 500 samples with sample size n equals 20, and then we're going to repeat it for n equals 60, comparing the distributions for the two different sample sizes. So let's take some notes. So when n is 20, what do we see? So let's go here. We'll put in our 20. And then I want 500 samples with that size. So I can only go in sample sizes of 1, 100, 1,000, or 10,000. So I'm going to hit this 5 times. 1, 2, 3, 4, 5. So here is the sampling distribution of the sample means. And so let's look at what happened with my mean and my standard deviation. So when I do the 500 samples, so 500 samples of size n equals 20, I see a mean of, what did I get? So 840,915 and a standard deviation of, let's spell that correctly. And what did I see there? So 295,670. Okay, great. Now let's go ahead and do the same thing, but let's do 500 samples of size n equals 60. We'll want to figure out what the mean is and the standard deviation. So we'll enter those in a second. And then also notice that we're still pretty much skewed right, but let's go ahead and now clear this out. So we'll reset. And now I'm going to go to sample size 60. And I'm going to do this 5 times. So 1, 2, 3, 4. Oh, and there it is, 500 simulations already. So what do I get now? I get that the mean is 842,915. And then for my standard deviation, I see that being 167,042. And so what we can tell here is that although this is still skewed, the samples with n equals 60 have a much smaller standard deviation. And we fix our spelling, smaller standard deviation. So that's one thing to note there. The other thing we can note, so also note that between the two samples, so these 500 samples, the mean didn't change much. The mean only changed by about 2,000. Let's just double check. So here we had about 840,000, and then here 842,000. So there wasn't a whole lot of change in the mean, but there was definitely a big change in the standard deviation. For part C, we want to determine if the conditions are met to approximate probabilities of the simulated sample means with sample size n equals 60 using a normal curve. So the first thing we need to think about is, what is the data like? In this case, we're definitely skewed to the right. So since skewed to the right, we need to have data larger. We need to have really n that is bigger than 30. But we're okay. This is okay since the n that we started with is actually 60. So we're able to actually use and approximate our probabilities using a normal curve. So yes, can use normal curve to approximate. Part D, we want to calculate the theoretical mean and the standard deviation of the sampling distribution using a sample size of n equals 60. Well, luckily for us, our statistical tool will do this. So far we can see here our approximation for mu. So we can have that our mean then is 834,857. But now for the standard deviation, we need to take what's given here as sigma, and we need to divide by the square root of n. So we will take, and maybe I can just annotate somewhere. So the thing that I'll enter in that box is 1261014, and then I have to divide by the square root of n, which in this case is 60. And so the value that we end up getting there, let me stop annotating. I will get, so I calculated this on my handheld calculator, 162796.20. For part E, we want to find the probability of taking a sample of individual contributions for Republican politicians in 2020, and we want to find an average greater than $1 million. Well, now we know that we can use our standard normal distribution. So I'm going to go over here and let's go ahead, find probability. So this is under the Shiny app with normal distribution. Now the mean we have listed here. So this is 834,857. The standard deviation we have as 162,796.2. And now what we want to know is find the probability that this average is greater than 1 million. So we want an upper tail of 1 million. Let's make sure I have enough zeros. There are 6 zeros, and there we go. So this looks to be about 0.15. So 15%, about 0.15 here. Let's look at the last part of this problem. Part F. Political analysts want to compare the contributions of Democrats with that of Republicans and take a sample of contributions to 60 Democratic politicians from the same election year. Their sample had a mean of $1.9 million. Assume that the standard deviations of individual contributions for politicians in both political parties are the same. Is there evidence to suggest that Democratic candidates received more, on average, in political contributions than Republicans? Alrighty, so that was quite the mouthful, but what we want to do is let's use our normal distribution statistical tool. What we want to do is see what is it probability wise that the Republicans are going to receive $1.9 million in contributions. So basically, let's use the information we found in the previous part. So for Republicans, we had that the mean was 834,857. We're assuming the standard deviation, after we calculated it from our samples before, was 162,796.2. Okay, now let's think about what we're trying to compare. So they took this new sample for Democrats, and there they found that the average was $1.9 million. Now for the Republicans, the average was about 834,000. So it does seem very unlikely that there's going to be many people who are donating 1.9 million. Let's check that. So we're going to compute an upper tail. So we want to know the proportion who donated over 1.9 million. So let's make sure I have enough zeros there. There we go. And sure enough, look at this. That is 0. So yes, it is very likely that the Democratic candidates receive much higher donations, much higher, I guess I should call it contributions, higher contributions than than the Republicans. Since the p-value, since the proportion, the probability that X is bigger than 1.9 million is essentially 0, as we noticed in our use of the normal distribution tool. So let's just spell this correctly over here. I guess it's I after E. There we go. Perfect. So that completes that problem.